Here's solutions to quiz 2 for Math 251. We're given some mess of a graph, this big piecewise mess, and asked to evaluate the following limits, or say that it's undefined. The limit as x approaches 1 from the positive side of this function here. Well, here's where x is equal to 1, kind of right in here. But I want to approach this point from the positive side. So think about it like you're walking down this line here, and you're getting really, really close to 1, but not quite to 1. Your height would be really, really close to, looks like 1 here. So this answer is 1. The limit as x approaches negative 1 from the negative side. So similarly, here's negative 1. Here's where x equals negative 1. And I'm walking along the line. I'm coming from the negative side, so I'm coming in from this direction. So it looks like my height is getting really, really close to 3 when I get really, really close to negative 1. So I'm going to say this equals 3. Limit as x approaches 0 from the positive side. Here's where x equals 0. I'm coming from the positive side, so I'm not coming on this line. I'm coming on this line here. Height, I don't know. Kind of wish that was on 3. It looks like it's a little bit below. Whatever. I guess it would be like 2.9 or something here. I'll put in 2.9, but really, maybe I'll even say or 3 or similar. I wish I had a prettier picture there. This height being 2.9 is a little bit weird. But it's not because I haven't quite reached 0. It's because the height of this open circle here looks like on the picture it's a little bit below 3. The limit as x approaches 1. It doesn't tell me which side I'm coming from. So the way I figure this out is I have to look at the limit as x approaches 1 from the positive side, and I have to look at the limit as x approaches 1 from the negative side. I already figured out that when I approach 1 from the positive side, I get close to a height of 1. Turns out that as I approach from the negative side, I also get close to a height of 1. So this is going to equal 1, and maybe I'll even write parenthetically, because the limit as x approaches 1 from the positive side equals the limit as x approaches 1 from the negative side, which equal 1. You don't have to write all this. This is just me explaining my answer to you if you're looking at my solutions after the quiz. And then finally, the limit as f of x, the limit as x approaches negative 1 of f of x. So now we're back over here. It doesn't tell us which side we're coming at. So because the limit from the negative side is different than the limit from the positive side, what that means is this is undefined. This is undefined, and maybe again parenthetically that's because the limit as x approaches negative 1 from the negative side, which I figured out was equal to 3, is not the same as the limit as x approaches negative 1 from the positive side, because when you approach negative 1 from the positive side, you come in at a height of whatever the hell that is, I don't know, 0.8 maybe? So from one side we get 3, from the other side we get 0.8, so it's undefined. You don't have to tell me why, just say undefined and you're good. All right. Maybe a little bit more difficult than those. Although I guess these are, if you know how to do them, they're easy. And if you don't know, they're impossible. So maybe that makes that difficult. I don't know. I think these are a little bit more work involved in finding the answers. We're asked to evaluate these limits without using a calculator. The way you do that is you take advantage of the fact, well, you take advantage of some properties of limits. So what I'm saying is it would be nice to just change all the h's into zeros right off the bat. But we can't, because if we try to evaluate that, 3 plus 0 is 3, squared is 9, 9 minus 9 is 0. And if this h were 0, we'd have 0 over 0, which is undefined. So we can't just change all the h's into zeros. So what we want to do is say that this is the limit as h approaches 0 of, we want to simplify this thing. 3 plus h squared is 9 plus 6h plus h squared. So if I just expand this binomial, I get this. And note that now the 9 and the negative 9 cancel out. So I guess the limit as h approaches 0 of 6h plus h squared divided by h. This h is what's causing a problem. It's changing this into a 0, which is making things undefined. So really I want to cancel it out. And I can because I have an h in every term of the numerator. So you could factor out an h from every term in the numerator and kind of cancel out those h's. Maybe I should show that in another step. This is the limit as h approaches 0 of h times 6 plus h over h. It's tempting to want to just cancel out these h's, and I mean, it's right, actually, that is what you do, but I want to talk about that a little bit. Turns out that that is equal to this. You can cancel out this h and this h, not because this right here, this whole thing that I'm circling, is the same as this. It's not. You can't just cancel out h's normally, but because we have limits out in front, I can. This fraction right here is not the same as this. Like, what do you mean it's not? I just canceled out h's. Doesn't that make it equal? It doesn't. This is the same as this everywhere except for when h equals 0. If h equals 0, this thing equals 6. This thing is undefined. That's different. So this is not the same as this. But because they're the same at every single point except for that one point, the limit as h approaches 0 of these two things is the same. So it's key that I leave this limit out here if I want to go from this step to this step. Right? It's key that this still says limit here, otherwise these wouldn't be equal. Anyways, this is a limit I can evaluate. I couldn't evaluate this limit immediately because it gave me this undefined thing, but I can evaluate this. I can change all the h's into zeros. I can just say that's 6 plus 0, which equals 6, which is the answer. But really, it's the step from here to here, which is really subtle, and I guess it doesn't matter. Well, it'd be nice if you understood that subtlety. If it doesn't, you can still get the correct answer just by following the steps. But really, the subtlety that's built in here, this is not the same as this. But this, the limit of that thing, is the same as this. All right, moving on. Similar to the above one, you might want to change all the x's into 9s, but if you do, you'll get 0 over 0. Damn, it'd be nice if I could not divide by 0, because dividing by 0 in math is bad. It means I have to cancel out this x minus 9. How can I cancel out this x minus 9? Well, there's this nice little trick that I taught you in class that gets rid of square roots, that works in problems when you have these square roots, I guess is the best way to think about it. What you're going to do is you're going to multiply the numerator and the denominator by the conjugate of the numerator. It's called rationalizing. So it might just look like we're making things a lot worse, but we're not. We're not making things worse by including this term out here. Because when you FOIL things out, root x times root x is just x. 3 times root x is 3 root x. Negative 3 times root x is negative 3 root x. Negative 3 times 3 is negative 9. And what you'll see in the next step is things are going to cancel out very nicely up in the numerator. In the denominator, I don't bother foiling it out because I know what's going to happen. I know that this x minus 9 is what I need to get rid of, so I'm going to leave it like this. Positive 3 root x and minus 3 root x, these two guys cancel out. All I'm left with up top is x minus 9. In the bottom, I got x minus 9 divided by the square root of x plus 3. If this was not here, if I just had what's written here, I could not say that this is equal to 1 over the square root of x plus 3. I can't just cancel out these x minus 9s, except for the fact that I have this limit written here. This is not the same as this, but this is the same as this. These two things are the same everywhere except for when x equals 9. They're the same everywhere else. So the limit as x approaches 9 of these two things is the exact same. Therefore, this equals this. The advantage of this is something I can figure out. I can evaluate it. I can change my x's into 9s. I can say that this is equal to 1 over root 9 plus 3, which is 1 over 3 plus 3, which is 1/6. Is that the same as what I got up here? Nope, 6, which is the answer. All right, finally, the last one. Absolute values. The trick whenever you're taking a limit involving absolute values is to figure out what's the limit as x approaches 4 from the positive side of this thing. And then figure out what's the limit as x approaches 4 from the negative side of this thing. And if your two answers are the same, then that's your answer up here. If your two answers differ, then this thing is undefined. So let's figure it out. We're approaching, our value of x is getting close to 4 from the positive side. So in your head, you're thinking 4.00001. The absolute value of 4.0000001 is just 4.0000001. What I'm saying is when my x value is a little bit bigger than 4, the absolute value of x, let me write this here, the absolute value of x is just equal to x. Right? If I have a value bigger than 4, it's certainly positive, and absolute value doesn't do anything to a positive number. Down here on the bottom, if my value of x is a little bit bigger than 4, something a little bit bigger than 4 minus 4 is still a positive number. This thing down here is a positive number. So these absolute value signs aren't doing anything either. So I don't need to write them. The limit as x approaches 4 from the positive side of x minus 4 over x minus 4, these x minus 4s cancel out, and I get that this is just equal to the limit as x approaches 4 from the positive side of 1, which is just 1. No variables here, nothing to change x's into, it's just the number 1. It's equal to 1. In other words, this, well, I'll leave it at that. It's equal to 1. So let's work on it over here. Same logic applies. The limit as x approaches 4 from the negative side. Now I'm thinking a little bit less than 4, 3.99999. It's still a positive number, so the absolute value sign up here still isn't doing anything, so I still don't even need to include it. I can just get rid of the absolute value signs around this x. However, down here it's different. Right? If I have a number a little bit less than 4, when I subtract 4 from that, I end up with a negative number. If you think about what the absolute value does to a negative number, it changes it and makes it positive. Mathematically, I could say it multiplies it by -1 to change it from a negative to a positive. So if I'm going to drop these absolute value signs, I have to recognize that what's inside them is a negative number, and so what the absolute value signs do is it changes the sign. I have to put a negative right here. So because x is a little bit less than 4, I need this negative here. So what I'm figuring out is the limit as x approaches 4 from the negative side of, if I cancel these out, I get -1. The limit as x approaches 4 from the negative side, The limit as x approaches 4 from the negative side of -1. There's no x's, there's no variable here. This is always just -1. So my answer is just -1. The limit from the positive side is 1. The limit from the negative side is -1. Therefore, this thing is undefined. And the reason why is because these are different. When I say these, I'm talking about this thing and this thing. That's the end of the quiz.